Hello everyone. In this video, we are going to see about transaction. So the outline of this presentation is introduction to transactions, what are the operations we can perform using transactions, the asset properties of the transaction. Finally, we are going to see about the states of the transaction. Normally, a transaction is a set of logically related operation. It contains a group of tasks. It may be a single action or a series of actions. It is performed by a single user to access the contents of the database. Take for an instance, if you are transferring an amount from one account to another account, that's an example for a transaction. In day-to-day life, we used to see what is transaction. Now we are going to see about the operations of transaction. There are four operations in transaction: read operation, write operation, commit, and rollback. The read operation is used to read the content of the database and store the data in the buffer which is available in main memory. Write operation means it is used to write the value back to the database from the buffer. That is, writing the content from main memory to the database. Let us take an example here. Read of x and x equal to x minus 500, write of x. So in the first instruction, the value of x is read from the database and stored into the buffer. The next instruction, the value of x is deducted by 500, again it is stored in the buffer. When write of x is executed, then only the content from the buffer is stored into the database. The third operation of a transaction is commit operation. It is used to save the work done permanently. When all the operations of the transaction completed successfully, commit is executed, then the data from the buffer is stored into the database permanently. The next operation is rollback. It is used to undo the work done. For example, there is a cancel of transaction. Undoing the transaction means when the rollback is executed, it is used to undo the work done. So we discussed the four operations of the transaction: read, write, commit, and rollback. The next concept is the asset property of a transaction. This is an important concept. Asset property of a transaction. The transaction must satisfy these four properties. The properties are atomicity, consistency, isolation, and durability. Let's see what is atomicity. It states that all operations of the transaction takes place at once. If not, the transaction is aborted. So, the transaction has to be completed successfully or not at all happened. This property is known as atomicity property, which means there is no midway. The transaction cannot be in the partial state. Either it should be in completed state or not at all the transaction is started. The atomicity property involves two operations. One is abort, another one is commit. If the transaction is not completed successfully, then the abort operation is executed. Then it calls rollback to undo the transaction. The transaction is completed successfully, then it goes to commit and all the changes are made available in the database. The next property is called as consistency property. The integrity constraints are maintained so that the database is consistent before and after the transaction. We saw about the integrity constraints, unique constraint, null constraint, check constraint, default constraint, primary key, foreign key, all are called as constraints. So the integrity constraints are maintained so that the database will be in the consistent state. So the execution of a transaction will leave the database either to its prior state or a new stable state. When it is committed, it goes to a new stable state. When the transaction is aborted, it goes to the prior stable state. So the consistency property of the database states that every transaction is a consistent database instance. The next property is isolation property. It shows that data which is used at the time of execution of a transaction cannot be used by the second transaction until the first one is completed. As an example, if there are two transactions T1 and T2, both are trying to access the data item X. In this case, T1 accessing the data item X means until the completion of T1, T2 cannot be started. So this way of execution is isolation. Until T1 is completing the transaction and releasing the data item X, T2 cannot access the data item X. So each transaction is being executed independently. Each transaction holds its resources independently. Control subsystem of the DBMS enforce this isolation property. The next property is durability property. The durability property is used to indicate the performance of the database consistent state. It states that the transaction made the permanent changes. That means when a transaction is completed, it goes to the new consistent state. Consistent state cannot be lost even if there is a system crash or system failure. So the durability property ensures that how long the database is in consistent state even there is a system failure or system crash. The recovery subsystem of the DBMS has the responsibility of the durability property. So we discussed about the four properties of the transaction: atomicity, consistency, isolation, and durability. Let's take a case study here. Just think about the ACID properties applied to a Netflix online streaming platform, especially managing the transactions related to user subscriptions, video playback, and recommendations. For these scenarios, how the ACID property works in Netflix. Just think about it. How the atomicity is maintained here, how the consistency is maintained here, how the durability isolation works here. You please think and identify. The last concept which we are going to discuss in this video is the states of the transaction. There are 5 important states of the transaction. Initially, the transaction is an active state. For example, DML operations are being executed. Insertion, updation, deletion. In that case, the transaction is in active state. And it goes to partially committed state when all operations are completed and the transaction is about to complete, not completed state, about to complete. In that case, the transaction will be in partially committed state. There is any failure during the initial state itself or in the partially committed state, it goes to failed state. For example, there is any IO error, memory devices error, if there are any errors, it goes to failed state. Once all operations are completed, the transaction will be in committed state. In this state only, all the changes made in the database will be stored permanently. Suppose if any kind of failures, the transaction is failed state mean it will go to aborted state. In that case, the rollback is called upon. The transaction will move to its prior state. Okay. Suppose if the transaction is in failed state, it cannot go to the committed state. It can go only to the aborted state. In the transaction is being ended. So these are the 5 important states of the transaction: active, partially committed, failed, committed, and aborted. So this is what given here. During the active state, every transaction is being executed, and during the partially committed state, the transaction executes its final operation, but the data is still not saved to the database. In the committed state, the data will be permanently stored into the database system. In the failed state, the data will not be stored into the database, and here rollback will be called. Aborted state means if any one of the checks fail and the transaction has reached a failed state, then the database recovery system will make sure that the database is in previous consistent state. For making the transaction to the previous consistent state, the rollback is called. So if the transaction faces any aborting condition, the operations may be restarted, that is the transaction may be restarted, or the transaction will be killed. If the transaction reached the aborted state, either the transaction can be restarted or it can be killed. Thank you for listening this video. Thank you.